Hi everybody and welcome back. In this lecture we will pre-process our cardiac MRI scans for the task of atrium segmentation. At first let's talk about the necessary libraries. We use pathlib for easy path handling, nibabel to load the nifties containing the cardiac MRI scans, numpy to save our pre-processed files, matplotlib for plotting, and tqtm to get a nice progress bar. Additionally, we use the magic command matplotlib notebook to increase the overall quality of our plots. Let's start by inspecting some sample data. To do so, let's define a root path called root, to which we pass a path object defining the path to all scans. In my case, it's task 02 underscore hard slash images tr. You can find the labels in the same path in a directory called labels.tr. As you can see, the images and labels are in two different directories. However, the file names in the two directories are the same. Therefore, we need to define functionality which replaces images.tr by labels.tr to simplify the process of loading an MRI scan with its corresponding label mask. Let us create a function called change image to label path, which accepts a path object. At first, we need to extract all parts or directories within the path. We can define a variable called parts, which will take the individual directories, to which we assign the output of path.parts converted to a list. This statement simply returns all directories within a path. When passing the root path to this function, the first element within the list would be task02 underscore hard and the second one images tr. Next, we need to replace images tr by labels tr. To do so, we need to access the index of our parts list which contains images tr. We can write parts where we access parts.index of images tr. This statement returns the position or index of the string images tr in our parts list. We can now override the list entry defined by this particular index with labels tr. Alright, we successfully replaced the path. Last but not least, we simply create a new path object by concatenating our modified parts list by using the star operator and return it. Let us now choose the first subject in our root directory as sample. We can define a variable called sample path and now use the glob function provided by pathlib, to which we pass LA star, because all files within the train directory start with LA, which stands for long axis. We directly convert the returned generator to a list and simply access the first element in it. Additionally, we can directly store the label path by using our helper function from above. Alright, let us quickly take a look at the sample path and the sample label path to make sure everything worked. Perfect! We can beautifully see how images tr got replaced by labels tr. We can now use nibabel.load to load the cardiac MRI defined by sample path and the corresponding label mask defined by sample path label. Additionally, we directly extract the numpy arrays by calling get_fdata on data and label respectively. Note that as our labels only consist of integers, we use s-type to convert the type to an unsigned integer. We can quickly check the orientation of this scan by using nibabel.affine to xcodes, to which we pass the affine matrix of our MRI. As already discussed in the introductory lecture, the orientation is RAS. We will later check in the pre-processing loop that all scans have this orientation. We are now ready to inspect the data. Let us use the sagittal view as it provides the nicest images of the hearts. A great tool to visualize such volumes in Jupyter is celluloid. We can use it to capture each slice of a scan and create a video afterwards. Let us quickly import the camera class from celluloid, followed by the HTML class from ipython.display to convert the returned animation object into a really nice video. Now let's get to it. At first we define our figure using plt.figure, followed by the camera object from celluloid to which we pass our figure. Next we use the range operator to loop over the third axis of the scan, so we can use our loop counter variable I to access the corresponding slices of MRI and label mask with the same index. When working with scans that have RAS orientation, slicing through the third axis yields the sagittal view. Above all, we simply use plt.imshow to visualize the current slice with the bone color map. Now let us define a variable called mask underscore to make sure we don't override our original mask object, to which we assign a masked version of our current label slice. To achieve this, we use numpy.ma.masked underscore where, which accepts at first a condition and next the array to mask. In our case, we want to mask all elements which are 0 so that matplotlib does not display them. We only want to visualize the pixels corresponding to the left atrium. Accordingly, we first pass the Boolean expression that returns true for all elements that are 0 in the current slice and false otherwise. Then of course we pass our current label slice we want to mask. We now use plt.imshow to visualize this mask as an overlay of our current slice with an additional parameter called alpha to allow for some transparency. Let's simply use 0.5. Last but not least, we call camera.snap to store the current visualization. After the whole scan is processed, we simply call camera.animate to create the video. Please note that this rendering process might take some seconds. But when it's done, we have our visualization. Due to the fact that we stored our animation object above, we can now call the HTML function to which we pass animation.to_html5_video. This converts our animation to an HTML5 video and directly visualizes it in the Jupyter Notebook. In this video, we can nicely see that only the pixels associated with the left atrium are visualized. All others are masked and thus not visible. Note that you can also download the video or pause it. Before moving on, we should pause this video and stop the animation above, as otherwise Jupyter might sometimes stall. Alright, now we are ready to pre-process our data set. We will continue from here in the next lecture. Thanks!